Removing duplicate and biased responses in market research. In market research and customer analytics, duplicate or biased responses can badly distort insights and mislead business decisions. A typical challenge: some customers fill out surveys multiple times, or you receive patterned answers that suggest bias or bots. Cleaning the data by removing these issues is crucial for accurate analysis. In this lesson, you will learn practical Python tools to detect and filter out untrustworthy survey and feedback data. You will gain the ability to identify and correct common biases so your analysis supports better business and customer understanding. Running the cell now. We import pandas as our core data table tool. We import numpy for numeric and random operations. We import OpenML to access real business datasets directly. We import warnings to suppress unnecessary alerts. We suppress warnings for a cleaner output. Running the cell now. Understanding your customer and market data. Market research surveys may ask demographics, satisfaction, NPS, or open feedback. Data is usually one row per response, with columns for each question or customer attribute. Common beginner errors include counting duplicate survey responses as independent data, not screening for patterned or biased answers, like giving maximum score to all questions, forgetting that missing or repeated responses must often be filtered for reliable insight. Running the cell now. We start by loading a real customer satisfaction survey to practice finding questionable responses. We fetch the customer satisfaction dataset from OpenML. We convert the data to a pandas data frame so we can work with it easily. We print the number of rows and columns to see how large the survey is. We preview the first 3 customer records for an initial inspection. Running the cell now. This dataset contains 7,043 customer survey responses with 20 attributes each, such as demographics, service usage, and churn status. Notice the consistent one-row per customer format, which ensures each response is uniquely counted, key to avoiding errors like double counting. This setup lays the foundation for accurate market and customer analysis in later lessons. What are some columns you think could help identify duplicate or biased responses? A common source of duplication is repeated survey entries from the same customer. We check if a customer ID column exists in this dataset. If yes, we use pandas to find duplicated customer IDs. We count how many duplicates are present, which may need removal. If the column is missing, we will need another strategy. No customer ID column found means we will need to look for duplicates using all columns or a subset. Running the cell now. This output shows that the dataset lacks a customer ID column, so the code cannot directly identify duplicate responses by customer. This highlights the importance of having a unique identifier to avoid counting repeat entries as independent data, a common beginner mistake in customer and market survey analysis. Sometimes duplicate responses match every value, including demographics and answers. We use drop_duplicates to remove rows that are exactly the same as previous ones. Display how many rows were lost, so we can see how much duplicate data existed. Show the new shape after cleaning. A smaller table means we have removed at least some exact duplicates. Running the cell now. The output shows a small reduction in the number of rows after removing exact duplicate survey responses, from 7043 to 7021, while the number of columns stays the same at 20. This confirms that a few responses were submitted identically multiple times, and dropping these duplicates helps ensure the data more accurately reflects unique participants. This step is crucial to avoid biasing analysis by counting duplicates as separate data points. Can you spot any patterns suggesting how exact duplicates might have been created? In some surveys, keeping only the first response from each customer makes the analysis fairer. Check for a customer ID column before applying this method. We drop duplicate rows with the same customer ID, keeping the earliest submission only. Print the resulting shape for comparison. If we do not have a customer ID, we cannot do this direct filtering. Running the cell now. The output No Customer ID field, skipping, indicates that the dataset has no customer ID column, so duplicate responses can't be identified or removed. This highlights the importance of having a unique identifier in survey data to accurately count distinct customers and avoid inflating results due to duplicate entries. Without it, the code's intent to filter duplicates cannot be applied, which could affect analysis validity. Why might someone submit more than one response to a survey? Sometimes duplicate entries look different due to missing IDs but share exactly matched demographic traits. Define a list of typical demographic columns to use. Only keep those columns that are actually present in the dataset. Check for duplicate rows across these demographic features. Report how many such duplicates may exist in your data. Running the cell now. This output shows there are 6,152 duplicate survey responses when considering key demographic columns, indicating many rows share identical core customer attributes. This highlights the importance of checking for duplicates to avoid inflating data counts in your market analysis. The code's intent is to ensure that each row represents a unique respondent profile before proceeding with deeper analysis. Try modifying the columns used in duplicate detection to balance strictness and flexibility. Let us create a synthetic NPS survey with repeating customer IDs to simulate real survey duplication. Set C to 42 for reproducibility. Randomly assign hypothetical customer IDs. Simulate a spread of ages. Assign regions to reflect geographic diversity. Generate random NPS scores from 0 to 10 as is common for these surveys. Preview a few NPS survey responses that we will analyze for duplication and bias. Running the cell now. This output shows the first 3 rows of a synthetic NPS survey dataset, with each row representing a customer response including their ID, age, region, and NPS score. Notice that customer ID is not unique, hinting at possible duplicate responses, which is a key issue to address when analyzing customer data. This example sets the stage for understanding how duplicates can affect data accuracy in market research. What would you expect if the same customer is present in multiple regions? Identifying customers who filled out the survey more than once is a key part of removing bias. We filter all records where customer ID appears more than once. Print the number of unique customers who provided duplicate NPS responses. Running the cell now. This output shows that 59 unique customers submitted more than one NPS response, indicating duplicate entries in the survey data. Noticing this helps us understand the importance of identifying and handling duplicates early, preventing inflated counts or biased analysis in customer satisfaction metrics. This step is crucial to ensure accurate insights from market research data. Practice: what is a fair way of handling multiple responses by the same person? Discuss or try both first and last. Sometimes it is better to keep a customer's latest response, assuming later answers are the most accurate or relevant. Add an explicit row index to preserve position for sorting. Sort so we can drop previous responses from the same customer, keeping the last one. Show the resulting number of rows after this cleaning method. Running the cell now. The output shows the dataset now has 95 unique customer responses, confirming that duplicates were removed by keeping only the latest entry per customer ID. This reduction ensures accurate analysis by preventing double-counting customers, which is a common pitfall in survey data management. Noticing the shape change highlights the importance of cleaning data to reflect true customer insights. Duplicates can distort the summary metric for the whole company. First, calculate NPS as % promoters minus % detractors, with all responses. Then, recalculate NPS after removing duplicates. Print the NPS value before duplicate removal. Print the NPS value after removing duplicate responses. Running the cell now. This output highlights how duplicate survey responses can skew Net Promoter Score (NPS) calculations. Notice that removing duplicates raises the NPS from -47.0 to -40.0, indicating the original score was more negative due to counting some customers multiple times. This demonstrates the importance of cleaning your data to get accurate customer sentiment insights. Notice how data cleaning can meaningfully change your key business metrics. If you would like to see a video about NPS analysis, try searching NPS metrics explained. Now we shift to campaign data. Patterned or biased answers can skew campaign performance metrics too. Load the marketing campaign dataset from OpenML. Retrieve it as a data frame for easy processing. Rename columns for clarity and meaningful analysis. Preview a few rows to inspect what customer and response data is present. Running the cell now. This snippet shows the first 3 rows of a marketing campaign dataset, where each row represents a unique customer response. Notice key demographic columns like age, job, and education, alongside campaign-related features like contact method and previous outcomes. This initial glimpse helps confirm the data structure and that rows correspond to individual responses, setting the stage for detecting bias and avoiding double-counting duplicates later in the lesson. If an actual ID is missing, repeated answers within the same core group can uncover evil twins or bots. Define a group identifier by combining age and job. Check for duplicates within the same group, contact method, and survey day. Print how many potential duplicate survey responses exist within these groupings. Running the cell now. This output shows there are 20,730 repeated survey responses from the same age job group contacted on the same day and month. Notice how the code creates a combined group identifier to catch duplicates across demographic and timing columns, highlighting the importance of identifying duplicate responses. This helps ensure accurate customer insights by avoiding inflated counts from repeat entries in market data. Try customizing the grouping columns for your own dataset's context. In free text feedback, identical or copy-pasted comments are also a source of analytic bias. Create a small synthetic feedback dataset with duplicate opinions and repeated customer IDs. Display the feedback table for inspection. Running the cell now. Here we see a small dataset with 1 row per open feedback entry, but notice that customer ID 2 appears twice with identical feedback. This highlights a key lesson: survey data can include duplicate responses from the same customer, which may bias analysis if counted as independent. Recognizing and handling such duplicates is essential for accurate market insights. What are some challenges of detecting biased responses in free text data versus numeric survey data? We remove entries where a customer gives the same written feedback more than once. Remove duplicates based on the combination of customer ID and textual feedback. Display the clean table, now free of repeated written responses from the same customer. Running the cell now. The output shows the feedback data after removing exact duplicate responses from the same customers, resulting in 1 unique row per customer feedback pair. Notice there are now only 4 distinct entries, ensuring we don't overcount repeated comments when analyzing customer sentiment. This step is crucial to maintain data integrity before summarizing or visualizing survey results. Can you think of survey construction practices to reduce free text duplication? Sometimes bots or copycats submit the exact same comment as someone else. Count the frequency of each unique feedback string. Extract those comments that appear multiple times as possible problematic responses. Print the list of feedback phrases that are repeated by different respondents. Running the cell now. This output highlights that the comment "Great service" appears multiple times in the feedback column, indicating duplicate responses. This is important because counting these repeated comments as separate insights could mislead the analysis by overweighting certain opinions. The code helps identify such duplicates to ensure cleaner, more reliable survey data for understanding customer sentiment. Patterned or biased survey answering, like always choosing the maximum, can point to gaming or inattentive responses. Find columns with very few categories, often yes/no columns, for this check. Filter rows where all of these columns are answered yes, suggesting very patterned data. Report the number of these suspicious survey responses. Running the cell now. This output shows that there are 0 survey responses where all yes/no questions were answered with yes. This suggests there is no obvious pattern bias or uniform all yes answers, which helps confirm data quality before deeper analysis. Identifying such suspicious patterns is key to avoiding misleading conclusions from duplicate or careless survey responses. Automated pattern scans are a best practice for market research surveys. If someone answers every question the same, this can suggest inattention or pattern behavior. List the optional, non-demographic, non-ID, non-target survey columns. Mark rows where all answers are identical for optional questions. Keep only the rows with valid, variable responses. Report how many people we have filtered for this low-variance pattern. Running the cell now. This output shows that no survey responses were removed because there were no respondents who gave the same answer across all optional questions. This confirms the data has meaningful variation per respondent, which is crucial for valid insights and avoiding bias from duplicate or uninformative entries. The code's intent is to ensure the dataset reflects genuine customer diversity before analysis. Practice prompt: how would you tune this filter to avoid unfair bias against legitimate customers? Many survey datasets have missing or blank values. It is important to check before filtering duplicates. Compute missing values for each column. Print any columns with missing data. These might require special logic in your cleaning step. Running the cell now. This output shows there are no missing values in the survey data columns, as indicated by the empty series. Noticing this confirms that our cleaning pipeline successfully handled or detected missing responses, ensuring each row of data is complete and reliable for analysis. This is crucial to avoid errors or bias when understanding customer feedback trends. Grouping by columns containing missing values can produce unexpected duplicate results. Filter core columns to only those with no missing data. Check for duplicates using only safe, complete columns. Print how many duplicates now result with this safer approach. Running the cell now. This output shows there are 6,152 duplicate survey responses when grouping only by columns without missing values, highlighting a key data quality issue. The lesson here is to carefully select columns for identifying duplicates to avoid inaccuracies caused by missing data, ensuring a reliable count of unique responses for market insights. Extreme values across all Likert or scale items are a classic sign of low effort or biased responses. Find numerical columns with a small number of unique values, typical for scales. Select respondents who picked exactly the same extreme value everywhere, like all 0 or all 10. Report these suspicious Likert responses. Running the cell now. This output shows 0 extreme Likert responses, meaning no rows had the same minimum or maximum value across all key Likert or NPS columns. This indicates the data likely avoids the common error of duplicate or overly simplistic survey answers, helping ensure more reliable customer insights in this section on data quality checks. Be cautious not to remove valid but enthusiastic responses. Common patterns for reliable analytics. Always segment your analysis after cleaning, for example by demographic or channel. Cross-tabulation helps detect duplicate or improbable patterns, for example same answer across very different ages. Build trustable scores and indices only using deduplicated, filtered responses. Compare trends before and after cleaning to explain the impact of your data hygiene. Running the cell now. Let us apply a complete pipeline to find what contract type best predicts churn, after removing problematic responses. First, drop identical duplicate submissions. After that, filter out those who answer every optional question the same. Remove rows where all yes/no questions are at their maximum or minimum. Finally, for each contract type, calculate and print real churn likelihoods using only quality check data. If the contract or churn column is missing, inform the user. Running the cell now. This output shows the proportion of customers who churned versus those who stayed, segmented by contract type after rigorous data cleaning. Notice the clear trend: churn rates are highest for month-to-month contracts and drop significantly for longer-term contracts, illustrating how deduplication and filtering reveal more reliable correlations. This step highlights the importance of cleaning and segmenting data to uncover trustworthy insights in customer behavior. You can repeat this analysis on other target outcomes or surveys. To see a real analyst walk through this, try searching YouTube for Survey Data Cleaning Python.